In this video, we are going to discuss some strategies for finding missing sides in 45, 45, 90 triangles. And so we're going to look at how to find those missing sides using equations and proportions. So let's start with using equations to find those missing sides in a 45, 45, 90 triangle. Remember in a 45, 45, 90 triangle that it is an isosceles right triangle, meaning we have our legs, which we know are congruent to each other, and then our hypotenuse. And so we learned through our explorations in class that our hypotenuse is equal to the leg times root 2. And remember that our legs are the sides that make up the right angle, and our hypotenuse is the side that's directly across from the right angle. So directly across. Now, when we solve problems involving 45, 45, 90 triangles, we don't always have to use equations. There are some problems that kind of follow this pattern easily where our legs are the same and then we see the hypotenuse as the leg times root 2. And if we look at this first example, we have 4 root 2, which is the hypotenuse. And so this number out front is actually the leg. So we can go ahead and put our 4s there. But on this next problem, our leg isn't a whole number, it's a coefficient with a radical. And so for some of us, that could be a little overwhelming. And so that is where we can use this equation where the hypotenuse equals the leg times root 2. We can use that to our advantage. And so in this problem, when I see that my side is 3 root 2, that side is actually the leg. So I'm going to substitute 3 root 2 in for the leg. And I get 3 root 2 times the square root of 2. And so when I multiply those together, I get 3 times the square root of 4. The square root of 4 is 2. 3 times 2 is 6. So my hypotenuse is going to be 6. And then the other leg is still 3 root 2. In the last example, my hypotenuse is a 10, and I'm being asked to find the legs. So once again, I can use this equation because it doesn't follow the pattern nicely. Like I don't see that root 2 in the hypotenuse. And so I'm going to use my equation to work backwards to figure out what those legs have to be. So in this case, the 10 is my hypotenuse, so I substitute that in here. So I have 10 equals the leg root 2, which since I'm solving for the leg, I'm going to think of it as an x. And so now if I want to get x by itself, if I'm multiplying by the square root of 2, I'm going to divide by the square root of 2. And we get that x equals 10 divided by the square root of 2. However, if we remember from our radicals unit, we are not allowed to have radicals in the denominator, so this is going to cause us to have to rationalize. So I'm going to multiply the numerator and denominator by the square root of 2, which will give me 10 times the square root of 2 all over 2. And then I need to check the coefficients, and I can see I have 10 divided by 2, which simplifies to 5 root 2. So my legs will be 5 root 2. So that is how you can solve for missing sides in a 45, 45, 90 triangle using equations. But now let's also look at a second way where we can use proportions. So in order to use proportions, we need to understand that if we're looking at only 45, 45, 90 triangles, that means that all of those triangles, as long as the angle measures are 45, 45, 90, every triangle I'm given, they're all going to be similar to each other because of the angle-angle similarity postulate. So I'm going to use this very basic 45, 45, 90 triangle where my legs are 1 and my hypotenuse is square root 2. And so any triangle that I'm given after this, I can create a proportion comparing the hypotenuse to its leg. So I'm going to use square root 2 and 1 as one of my ratios, and then the other ratio in my proportion will be for the triangle that's given to me. Now, in this first example, once again, This follows that pattern really nicely where I can see that the hypotenuse is the leg times root 2. I have a root 2 there, so that means that 4 sitting up front are the legs. But in these two examples, it's not as, it's not such a clear-cut, easy example or problem like what we've been looking at. So I'm going to use proportion to solve. So I'm going to create a ratio or a proportion comparing the hypotenuse to the leg. So I'm going to use my basic triangle. So my hypotenuse is square root 2 and my leg is 1. And in this problem, I was given the leg. So I'm going to put 3 square root 2 in the denominator. And then since I need to know the hypotenuse, I'm going to put an h there because that's the part I'm missing. So when I cross multiply, I get h equals 3 square root 2 times square root 2. And if you look above, when we did it with an equation, see how we have the exact same equation there as we do from the proportion? The proportion is just another way to think about how to set up an equation, because at the end of the day, proportion, when we solve proportions, we typically just use equations to finish up and solve that problem. And so that's what happens here. So when I multiply, I get 3 times the square root of 4, which we know the square root of 4 is 2. 3 times 2 is 6. And of course, the other leg is 3 root 2. And in the last example where I'm given the hypotenuse, once again, I can use the ratio of comparing the hypotenuse to the leg. And so in my basic triangle, that would be square root 2 over 1. And that's going to be equal to, now in this case, since I have the hypotenuse, I'm going to put the 10 in the numerator. And then I'm solving for a leg. So I'll put L, or if you want to use X, you can put an X there. So when I cross multiply, I get L times the square root of 2 is equal to 10. And once again, if you look at this equation, it's the same equation that we ended up with using the other method. So I'm going to divide by the square root of 2. And I get L equals 10 divided by the square root of 2, which I have to rationalize. And then simplify the coefficients. And I get 5 root 2 again. So it does not matter to us which way you may use. You may decide you like to set up and use proportions. You may decide you like to set up and use an equation, or some of you might be able to do it mentally in your head. But at the end of the day, this graphic organizer is designed to give you some extra strategies and tools in your back pocket to help you be successful with 45, 45, 90 triangles.